Great, this actually works. Let me get a timer going as well. Right, perfect. Thank you very much. Today I'm going to talk a little bit about multi-chain settlement, not necessarily with Anoma, but rather into sort of in specific consensus systems that we can deploy in order to achieve multi-chain settlement. So with that, let's get started. So this is mostly talk on Typhon and Chimera chains. And one sort of simple way to think of Typhon and Chimera chains is that they generalize shared sequences. A shared sequence is generally something that can settle across multiple systems that tend to have the same trust assumptions, but Typhon, on the other hand, is designed for heterogeneous trust assumptions, which is really the model that all chains are currently operating in, outside of sort of things built on top of Ethereum. But sort of when you think of Linus, Solana, Ethereum, Cosmos, these are all heterogeneous trust assumptions. And I mean, I sort of spoke a bit about this earlier on the panel. I think heterogeneous trust assumptions is really what most people will want, because not everyone is going to want the same security model. Most consensus implementations currently aren't aware of cross-chain opportunities. So like the consensus implementation has no idea what the state machine does with regards to cross-chain messaging. Typhon, on the other hand, here is actually aware of cross-chain opportunities and can take advantage of them. And this enables cross-chain atomic bundles with arbitrary rounds of synchronous messages between transactions on different systems. And I'll sort of go through a specific example in a little bit to make this a little bit clearer. I think one thing we're definitely looking for collaboration on, which I think a lot of people are starting to think about, is what does the API surface, both from a user perspective, a solver perspective, as well as a developer perspective, actually look like for cross-chain, both applications as well as intents. So if you're working on this kind of area, yeah, please find me afterwards. And maybe one other thing is, the important thing here is the trust assumptions are not baked into the consensus protocol, into Typhon and Chimera chains. This can range from proof of authority to proof of work to proof of stake to local government chain, whatever you want. This is completely trust assumption agnostic. So why do cross-chain atomic transactions actually matter? Well, for one, I think the future is going to be very much multi-chain as well as multi-trust. It seems unlikely that we'll standardize on exactly the same chain with exactly the same trust assumption for 7 billion people across the world. This just seems like an unlikely outcome. So I will start with this very basic example of we have a train chain in green and a hotel chain in blue. And the thing that I want to achieve is I want to be able to book a train if and only if I also get a hotel at the same time. So there are a couple of requirements here. One, we must schedule both transactions on both chains, right? This is sort of similar to the shared sequencer concept that Espresso System has been talking a bunch about. But this is actually not enough. We don't just need that both chains include both transactions, we also must have them succeed on both systems at the same time. We can't have the green transaction fail, the blue transaction succeed, right? So we also need something that Umbra Research has been working on called shared validity sequencing. However, sort of both shared sequencing as well as shared validity sequencing really works in the model of uniform trust assumptions between the systems being connected here. With Chimera chains and Chimera petitions, we can actually allow for atomic commits based on specific trust overlaps. So imagine that you have a trust overlap between blue and green and blue and red, but not red and green. In this case, we can form atomic commits between the two things that have trust overlaps, but not between the things that don't have trust overlaps, unless we elect something else to provide uniform trust to both systems. One of the nice things is every one of these chains can form effectively state petitions, and you have two types of state petitions within each chain. Each chain in Typhon has a base chain, which really defines the quorum that allows updates to the chain to happen. Think of this as the blockchain that defines proof of stake as well as validator sets and rules on how to transition the blockchain forward block by block, right? And then we have chimera partitions, which are where chains can move state that we want to get atomic settlement with respect to other chains. So for example here, the red chain can have a chimera state partition that forms effectively another chain in the middle here between red and blue that is atomic to both systems. And we'll go over this, what this means in a little bit. So yeah, this is just the way the base chain looks. Again, this is a normal standard blockchain, nothing really new here. This is effectively running PBFT or any other consensus that you'd like. Okay, now we've come to these chimera partitions. So this is one chain, this is one blockchain. You have the base partition, you have some state partitions or chimera partitions. And these chimera partitions may contain arbitrary state. For example, they can contain things like a specific hotel room that is bookable. The nice thing is, it is relatively cheap to move state between the different state partitions on a single blockchain, and every state partition can read from every other state partition within the same chain a number of blocks back. So you can read recent data, which means you can actually do very quick unlocks where if, for example, this state partition gives up control over a specific hotel room, the other state partition that may be trying to form a chimera chain with a different blockchain can very quickly figure out, oh, the hotel room is now unlocked on this state partition, it is now available over here. And they can effectively take the lock there. Yes, this is how the starts look, and I'm realizing the diagrams are very small for the screen, with multiple chains. So we have, again, train, hotel, plane, and this here on the hotel one is effectively the chimera partition that wants to have an atomic commitment together with the train partition. And yeah, so you can only move state, like you cannot move the same hotel room to both state partitions, you can only move to one of them. Thereby you have no conflict between these and, well, this and this. Yep. And really, one of the simplest mental models you can form is that Typhon with chimera partitions enables on-demand blockchains. So this is sort of what we historically call a blockchain. These are three different blockchains, and whenever you want to do an atomic settlement between between any number of them, you form this chimera chain, which is really, you can view as a virtual blockchain that just gets spun up on demand in order to execute a specific cross-chain settlement that you'd like. Yeah, and so now we get to atomic bundles. How do these atomic bundles actually look? Well, Anoma is all about intents, and I think everyone is sort of slowly starting to realize that really everything in the future will be intents because they're by far the best abstraction for what users actually want to do with these systems. So in this case, users will issue intents that say, I want to book a train as well as a hotel, and I want to do so atomically. Users will have to pay for this, right? Like, this is not free, but users can decide how much they want to pay, and if this is above the actual cost of executing this, then these chains can form effectively chimera chains. And then solvers can form these atomic bundles. So this is a nice thing. A user does not have to figure out how to interact with all these systems. A user just has to, in their intent, define the settlement condition and the atomicity guarantees that they care about. So then the solver sort of picks this up, figures out how you want to combine these things, and now you get to an atomic bundle, which is being executed on this on-demand chimera chain. If you have perfect overlap between the security models of each chain, this looks very much like shared sequencing. However, you even get the atomicity guarantees as long as you have some amount of overlap. So this effectively generalizes shared sequencing to work in the model of complete trust overlap to no trust overlap. And it rather allows users and the ecosystem to sort of figure out exactly what kind of overlaps you want. And I'll go a little bit up. One important thing is I'm always using the example of like two chains forming a chimera chain because it's visually easy. You can have n number of chains forming chimera chains. You can have like 3 or 15 different chains forming one on-demand chimera chain onto which we can atomically settle things. Yeah, and overall this allows for us atomic cross-chain communication without any extra trust assumptions outside of what you have in terms of the underlying security models of each involved chain. And one of the really important things, which I think more people should be looking into database systems and database engineering, because effectively we're just partitioning this database of each blockchain according to where it wants to do atomic, or who it wants to do atomic settlement with. Yes, one of the really big benefits of this is that you can have that this is not a message-based protocol. This is not I'm sending a message over the wire, I'm waiting for a bunch of consensus rounds to happen. This is rather, this Chimera chain is executed by both validator sets, and the validators have access to the entire state. They're just running these transactions. They're just running transactions against the Chimera chain blocks, which means we can have synchronous message passing between these two blocks, right? So like, I can have book me a train transaction over here that within the protocol actually checks whether the hotel room is available, and if it's available, this returns true, and then it only executes. So you can have these a very atomic synchronous message passing with each other, which means that you don't have to rely on relayers or solvers to actually do this kind of work for you. Rather, you can have like a model that is very similar to how you currently program existing synchronous systems like an EVM. Yeah, and this is then how this starts looking if you have multiple ones of these at the same time. And really, the really nice component is that you can always read the state from the other partitions, not just the base state partition, but also from the Chimera state partitions. Yeah, so on to atomicity guarantees and sort of some of the benefits here of Typhon. The higher the overlap between the quorums of each involved chain, the stronger the atomicity guarantees. Really, if you have 100% overlap, your atomicity guarantee is as strong as the no forking rules on the involved systems. So, for example, in the case of BFT, this is generally 2/3 possible. These atomicity guarantees make Typhon behave a little bit like a bridge, except that we don't have to have an external bridge provider or operator that provides this consensus finality, but rather this atomicity comes from the consensus of each system jointly. And even if we lose atomicity guarantees because some people are misbehaving or some people are not well connected to the system, we don't lose safety. The worst thing that can happen is that the different chains order the transactions differently. So on one chain the hotel room was booked, on the other it wasn't. But it's not that we can double book a hotel room or that we can lose funds here. So yeah, this is really important. State is never lost, nor frozen, nor corrupted. Yeah, this is what actually ends up looking like if atomicity is lost. The Chimera chain just diverged. We didn't violate any of the rules of either base chain or either chain. We just happen to have a different view of the ordering of these resources. This is not great, but this is not like a critical failure effectively. And the other big benefit is that in order to get these atomicity guarantees, we don't have to do these multi-phase commits or sort of go through multiple consensus rounds, right? Like when you think of IBC, in IBC you always have to move assets first, lock them on some system, and then do actions on them. Here you don't. You don't have to move the assets. You also don't have to move an asset, lock it, freeze it for a while, and until you have all the assets frozen in place, and then you act on this. So you never lock assets unnecessarily. Yeah, so some future areas of research and collaborations that we're quite interested in. So exploring the continuum between liveness and safety. For example, you can not just take the overlap of both chains. For example, if you think of validators, that you don't just take the overlap between them, you could also take the union. So that this impacts your liveness a little bit, because now if more people go offline, you lose liveness earlier. However, it also increases the safety guarantees to some extent to not lose atomicity. One interesting area is also you can use a totally different quorum to connect two disjoint systems. So for example, when you think of how do you want to connect, for example, Nia and Solana, if they have no overlap in validator set, you could choose to use Ethereum as the common thing to run the Chimera chain in order to get atomicity guarantees across both things, or atomic settlement across between Nia and Solana, without them having to agree on a specific, on running the same security model. The other areas, intent layouts and formats, things like encoding formats for intents. I think as an industry, we just benefit from standardization here. One thing to keep in mind, they should be circuit friendly. The other thing is APIs for solvers, how do solvers actually interact with all these systems. And then application APIs. I mean, one of the sort of complex things here is what is the syscall interface that allows chain A to call a transaction on chain A to call into a transaction on chain B in the Chimera chain, and how to express different settlement functions. There are some resources and contacts. I would have you run all of these. Also check out generally the Anoma blog.anoma.net if you want to learn more. Also, we're on Twitter. I'm on Twitter. We're on Telegram. Come find me there if you want, or talk to me afterwards. Thank you very much.